What we're going to talk about today is variation functions. Okay, so starting off by talking about variation functions, what we want to look at are the different types of variations that we'll actually cover today. Okay, now first we're gonna talk about these 4 types of variations. We'll talk about direct variation. We'll talk about inverse variation. We'll talk about joint variation and combined variation. Okay. Now let's talk about which each of these are. Well, direct variation basically says y varies directly as x. So y varies directly as x. This is how this is represented. So it's written like this: y varies directly as x. Now you'll be able to see these. You'll be able to see this a lot better, what direct variation actually is, when we do some example problems. Now, direct variation is just basically a relationship between x and y that can be written in this form. Y is equal to the constant of variation, which is k, times your x. So k, that stands for the constant of variation. Okay, that's k. All right, so now let's talk about what inverse variation is, and we'll do some examples of these variations. Okay, well, inverse variation says this here. It says y varies inversely as x. Okay, y varies inversely as x. Okay, now if we actually say that y varies inversely as x, we're basically saying that y varies inversely as x means as y is increasing, x is decreasing, or as x is increasing, y is decreasing. Okay, and with direct variation, both your x and your y are increasing. Okay, so with inverse variation, only one is increasing and the other has to be decreasing. And then for direct variation, both are actually increasing, x and y. Okay, so we write this like this here: y varies inversely as x. Okay, now let's look at joint variation here. Joint variation basically says this here. It's like I said, it's a relationship between x and y among 3 variables, written in the form of y is equal to k, which is your constant of variation, times x times z. Okay? Now, how this is written, of course, you would go ahead and induce this statement. It says y varies jointly as x. Okay? Now, we'll actually introduce combined variation in just a minute here. I don't want to talk about it right now. I'm going to introduce it to you in a different way. But yeah, so these are the 3 different types of variations that we'll be talking about. Okay, so let's go ahead and start with direct variation. Let's get a couple of problems so you can actually see how this applies. Okay, let's say it says, given that y varies directly as x and y equals 10 when x is equal to 2.5. It says to write and graph the direct variation function. Okay, so if we're looking here, we want to basically, it says we want to find the relationship between x and y. So this is our key word here, directly. It says y varies directly as x. So that means we're going to have our equation, our direct equation, which is y is equal to k times x. Okay? Then here it says, and y is equal to 10 when x is equal to 2.5. Write and graph the direct variation function. Okay, the only thing we need to write this variation function is a k value, okay? Because if we use a k value, if we find the k value, we can find anything else. We can find, if we find k, we can find the value of x when y is a certain number. We can find the value of y when x is a certain number, okay? So let's go ahead and find k, and then we can use that. We can actually graph it by using k. Well, let's see. So it says, let's use the information given in order to figure out what this k is. It says when y is 10, so let's see, y is 10, x is 2.5, so 2.5. Now we can divide both sides by 2.5 in order to solve for k, so we can find out what our constant of variation is. So I have k is equal to 10 divided by 2.5, which will be k is equal to 4. Okay? Now, k is equal to 4. So what does that mean? Well, we just take this value of k, and all we do is substitute it back into the k for this equation, for our direct variation equation. So y is equal to 4 times x. And this is our direct variation function. Now, doesn't this indeed look familiar from your middle school math? Y is equal to mx plus b. Doesn't this look a lot like it's in that form, which is called the slope-intercept form? It does, because it is, but it just has a y-intercept of 0, okay? Well, if we remember how to graph that from middle school, it's going to be very simple to start graphing direct variation functions, okay? So let's take a look at here. If we say we have a y-intercept of 0, so we'll put it down here at 0, and it says 4x, so that means it's going to be 4 over 1. So we're going to rise 4, and then we're going to run 1. So we'll say rise 4, we'll say that's 4, and we ran 1, okay? Now, once we do that, all we have to do is just draw our line straight through those 2 points, and that is the graph of this direct variation function. Okay? Of course, this is a linear function here because the degree of this polynomial is the degree of this equation, is 1. Okay, so it's going to be a linear, which will be a line. All right, let's do one more, and then we'll stop this video and resume on the next here. Let's say, let's just substitute some more values in for here. Let's say, given that y is equal to 4 and x is equal to 6, write the direct variation function. Okay, well, that's pretty simple because that's what we just did. And it says graph the variation. So that's what we just did. So that should be pretty simple here. Okay, well, if it says it varies directly, so that means we're going to use a direct variation function, which is y is equal to, let me use a different color here so you don't get confused. That says y is equal to k times x. Well, it says, and y equals 4, x is equal to 6. So k times 6, because we can indeed solve for k by dividing both sides by 6. And then I'll have k is equal to 4 divided by 6, which would give me 2/3. So k is equal to 2/3. And if you want to express it as a decimal, it'd be 0.666 repeating. So I would just leave it as a fraction of 2/3. Okay. So this says that my constant of variation is 2/3. Okay. So if we want to go a step further, we can say that this is the what? This is the slope of this line. The slope or the steepness. The change in x divided by the change in y. You guys remember this, which is called the slope. Okay? Well, now that we've actually found that, let's go ahead and just substitute this k value into our direct variation equation. Well, y is equal to k times x, so this will be y is equal to 2/3 times x. Now, this here is the same exact thing that it's in the same form that I had before. Okay. Now, what is this form? We already know that this is y equals mx plus b form, which is the slope-intercept. So this is basically saying that I have a slope of 2/3 and a y-intercept of 0. Okay. So it's going to actually cut through the x-axis at 0, 0 again. So let's see how this graph actually looks here. I think I run off the board a little bit. Let me go over here. So it's y is equal to 2/3 x. Okay. So let's see. Y is equal to 2/3 times x. Okay, so let's actually see how this graph looks here. Well, 2/3. Okay, we have a y-intercept of 0, so it's plus 0, so we stay right here at that point, 0, 0. We don't go anywhere. Then it says 2/3, so it's the rise over the run. So we're going to rise 2, 1, 2, and then it says the run is 3, so we're going to run 3, 1, 2, 3. So look at this. Look at the slope of this line here. Look at how that line forms. Sorry, look at how that line forms there. Okay, so let's say that is 3, and then we went up 2. So that is exactly how this line here should look. Okay, this 3 should be just a little bit over, but I guess it's fine there. But okay, so we basically see how the graph of this direct variation function actually looks. Okay, well, let's go ahead and stop this video, and then we'll resume in the next video.